Hello, my name is Harry Cooper. I'm a landscape architect in Arizona, and I'm the branch manager for the landscape architecture and water conservation branch at the Flood Control District of Maricopa County. And today I would like to talk with you about the Durango campus parking lot landscape and water conservation retrofit project. And so in this discussion, we'll go over a bit about the project's background. We'll discuss the overall goals and objectives, some design themes and key features proposed in the design, and as well as discussions about data collection and research opportunities and performance monitoring post-construction. And then we'll end with a discussion of next steps, including tentative schedules about when we plan to construct. None of this would be possible without the help in design and production of construction documents with our design consultant team led by EPG and Mr. John Griffin, along with sub-consultants WERK Urban Design, Kimley Horn and Associates, West Consultants, and Nino and Moore. Slide here provides a bit of context, the blue line being the property in which we're proposing these design changes, and the red star being the Adobe conference room where this meeting has taken place. This is a aerial photo from Google to just show you the overall property from a different angle and to give you some sense of the amount of infrastructure that's already in place, as well as the size of the parking lot in relation to the overall property. And to really get to the start of our discussion here, to speak a bit about the district's role in stormwater management. And so the district's mission, the main focus here is protecting people and property from the damaging effects of flooding. And we've been doing that since 1959. And just a few years ago, we modified and updated our mission to include what you see here, which is that we recognize stormwater as a resource for the long-term benefit of the community and our environment. And that said, looking at these two images here on the screen, we're really talking about providing the flood control that we need through kind of standard traditional gray infrastructure, but also including green stormwater infrastructure as a flood control tool that also provides additional benefits to the community. Here, there's a lot of things coming together, and it's creating a great opportunity for a showcase project here. The property and the building are over 30 years old. They have a degraded landscape, pretty much a defunct irrigation system, and the parking lot needs a full replacement. And then you add to that drought conditions in the Southwest that have been continuing on now for 23 plus years. We're in what's considered a mega drought at this time. And just last year, the Bureau of Reclamation declared a shortage declaration on the Colorado River. And as of right now, we are in a 2A shortage, possibly transitioning into a 2B in the very near future. And then lastly, flood control is always looking to improve the way we do our work and to add tools to address evolving flood hazards. And this works well for us in order to help us improve our hydrology and hydraulic modeling, as well as including green stormwater infrastructure to address different types of flooding, particularly pluvial and urban flooding as we build out the urbanized areas.
Previous efforts getting here back in 2017, when Kaylee Coulter, who is a landscape architect in the Valley, she also works at ASU, she put together the original master plan and working with me on that. And it was, trying to put as many different features as possible into the space. And it was oriented around kind of a walking tour. In 2019, J2 came on board and helped us out with a feasibility and costing analysis to look at the overall campus, put as many things as possible in it and see if it makes sense. Can it be done? And is it cost effective or is it cost prohibitive? And that was looking at a 20-year time horizon. And it was trying again to include as many different techniques as possible. Then in 2020, EPG came on as a design consultant. We put out a benefits and merits report, which is looking at it again in a little more detail with a better design, one that's a little bit beyond conceptual, about a 45%. And then out of that, we felt comfortable enough to move forward with construction documents that were done in 2022. So throughout all of that, the project goals have pretty much remained the same. The major ones is reducing water. And so we have a goal of reducing potable water use on this property by 50%. I think we're doing that more so, where I think we're at 60+% as it sits right now. And then we want to be able to have use green infrastructure and low impact development techniques to better manage stormwater. And then the third goal is use this as an educational opportunity to showcase all the practices that are possible in the valley. So what makes this project different? So you know there's a lot of green stormwater infrastructure already out in the valley. You can see it when you drive. We've talked about different case studies that are around here. I think what makes this project different than some of the other ones that have been produced is that we're really looking at some of the background data. So it's a data-driven design. We're thinking about it holistically. We're trying to incorporate all of the interactions, all the different features, and not just putting it in there because it seems like a good place to do it. We're doing it for all the right reasons. We have actually done hydrology and hydraulic modeling on the site, which typically, from what I understand, is not done that often in this. We're still trying to include a suite of different features, so we have an opportunity to look at those and see how they perform, and that's going to help us out with educational opportunities. And then research and performance and maintenance strategies on that back end, which I'll talk about a little bit later. So one of the data-driven elements here is this water budget. This was done, Jesse might have to help me out with this one a little bit, to look at the potential that was the water availability that we had from rainfall, looking at what the plant demands were, and understanding how much potable water we would have to have. So if we're going to meet that 50% reduction, how many plants can we put in with the amount of rainfall that we have, and then how do we capture that for reuse at a later date when we have drier periods. So all of that was looked at from this water budgeting perspective. And some of the other key factors that I think are important to mention is that we're trying to look at the right plants and the conditions. We're not just putting in any plant. We're trying to put in drought tolerant plants that use minimal amounts of water and can establish and then eventually get off of irrigation, which is why we include a smart irrigation system with soil moisture sensors that can help understand when it's wet, we don't turn the water on, and then also that we have the ability to kind of turn off sections of the property altogether.
Yeah, I'll just add in real quick where it's a lot of times it's really easy just to say, okay, we're going to take this square footage and we can capture this many gallons of water. But when we were coming up with this was breaking things down by the month and knowing for us, you know, we get our biannual rainfall, we get our summer monsoon, and then we get our winter rains. But when everything is getting stressed, let's say like May and June, where we're not getting any rain, and then the demand for the plants is going through the roof on water requirements, that's when you start really seeing the potable water requirements go way up to capture that. So instead of just looking at it for the year, here's what we could capture, break everything down by the month, and then show what that is.
It shows us where our deficits are. Yeah, it's absolutely an important aspect. H&H, so this is definitely not my area at all. Maybe Brian will say something about it if I mess it up. But we use PC Swim for modeling. We actually modeled the entire property, divided it up into a bunch of mini watersheds. And then we, on the downstream end, we put in a feature. So we're going to have a swale that captures certain volume of water in that mini watershed. And we try to optimize that. So looking at, it could be a ½ inch of rain, 1 inch rainstorm. We stuck with the 1 inch. That was a 90th percentile rainstorm. So most rainfall events larger than 1 inch are pretty rare. And the idea there was to build our features and our passive and active capture with that 1 inch rainfall parameter. And so the graph here on the bottom left, actually I'll talk about this. So this is just us looking at the watersheds, trying to divide those. And then Kinley Horn went ahead and in the model, they broke it down into all these little watersheds. So each one of these, water will land in that space and then go into these red areas, which are the GI features, and then try to understand how big they need to be in order to capture the volume of water that lands in that space. Then this graph on the left-hand side is a simulated 1-inch rainfall event for the existing basin on the outside of the property. So we have 2 stormwater basins that you're required to have for the, I don't know what the size of the storm is, Brian, do you know? The 100-year, the 2-hour?
100-year, 2-hour?
So what this shows here is that the blue line is without any GILID in the upper watershed. And that was about 1.6 foot depth of water in that event, in that basin. And then this is with the GSI features installed in the upper watershed. So there's a reduction, 1.2 feet of water. So we're keeping 1.2 feet of water in a huge basin in the landscape areas where we want that water to be. Passive and active stormwater capture. So talking about this, these are fantastic graphics that Jesse put together, by the way. So kudos to you guys for doing that. They're great views on everything. The passive and active stormwater capture. What we're talking about here is on the passive side, it's wherever the rainfall lands on a parking lot or in the landscape area, it's immediate use by the plants, or it's getting infiltrated, or it's evaporating. But we're not doing a whole lot in terms of grabbing it, holding it. We're trying to use it right away. The active side ends up being the cisterns, which Jesse's group had a lot of work involved in that, putting that together. So we're capturing all of the water off of all of the roofs, all of the shade structures that we can, and then that's delayed reuse, and then we'll gather it, hold it, and keep it until we need it in the really dry months. Okay, so just the passive stuff here, rainwater harvesting basins. We've had a bunch of different features involved in that. So I think we did 6 or 7 different types of sediment traps and curb openings, so we can explore how those perform over time. We also have pavers, permeable pavers on top of soil cells, but then also in other areas without soil cells underneath. We have kind of the separated swale, linear swales through there. We have check dams as well installed. These are the 2 sheets from the plan set on the soil cells, which are really hard to read. They're huge columns in the ground. The thing here I think is really important to make sure we remember, it's not just for stormwater capture and getting it into the ground, which they're really good at doing, but it's also providing better root zone for the trees to grow, so they don't get compacted soils and die an early death in the parking lot. And then the sheet on the right, which is really super busy, and I did that on purpose, that's a grading sheet. We worked really hard at micro grading the parking lot and all of the landscape areas so that the water flows where we want it to flow. So capturing every bit of it that we can. Some active stormwater capture. So these are the 2 different examples of the above ground. This is underground cistern and then above ground cisterns. We have a total of 7 of them proposed with over 50,000 gallons of capture. And that would be, a few times over the course of the year. So we have winter rains come in, they fill up, and then again in the summer. And then the key point here is that almost all of the roof structure runoff is being captured. So that's this building, O&M, and then all of the shade structures as well. Another busy sheet here, just talking about all the drain connections for the shade structures. We have all kinds of piping that goes underground, gutter systems. It was pretty detailed work in order to try to maximize that capture. Then the O&M building as well, which is a different layout to an above ground tank on the backside. Important part here is that we have a cistern system set up that's all tied together with a controller with pumps that hook up to the potable water or to the irrigation system. And then they get pumped out like a normal irrigation system. But this particular example, what we're doing here is in the back of the lot, we have a tank that we're going to have it as set up as a gravity feed. So there's a different way of doing it, if you will. This is a graphic that Jesse's group put together, just showing what the overall, where we're harvesting the water off the roofs, and then looking at the gallons of water here, if you want to.
Yeah, so it's important to note what I said earlier, where, yeah, 307,297 is what, you'd be getting off of these blue areas. But again, when there's times when we're getting overflow amounts or we're hitting back-to-back rains, then we're not able to capture all that. But that still goes into our passive system and overflows into our basins.
All right, just a couple more here. And then again, we talked about the smart irrigation system using desert adapted plants. It's a real critical point, just to capture all this water and then put out a plant that uses 5 times as much water. Doesn't make a whole lot of sense. And we are including soil moisture sensors so we can have that irrigation system remain off until it has to come on. Right plant in the right place. I know you've heard that from tree and shade master plans, but it's important to think about that in terms of GILID as well for the inundation zone. So part of the work that Wayne had done on the back of the LID handbook was talking about where do you put plants. You don't put a prickly pear cactus in the bottom of the swale where it gets wet roots all day long. And it doesn't need to be there. It needs to be up and away from the water. But other plants like grasses may need to be down in the hole. And so we attempted to do that. And we want to be able to come back and look at how successful we were in that work. Again, the tall pot trees, native seeding, and then the watering for establishment. So the idea here is that we are looking at installing an irrigation system that we are eventually going to just keep turning it back and get all the plants established and then just slowly turn it off. Some areas get completely turned off and other areas will have it on, but only when it's really needed. Durango Street. We are also looking to be connected to the community a bit. So we know that the road you came in on Durango, that road has been flooded numerous times in the past couple of years, and it's because their storm drain is undersized. And so they can go in and build a new storm drain in there at a cost of millions of dollars, huge impacts to the road. And but what we're doing is installing a series of scuppers, mag scuppers, just reversing them and picking up the water off the street and bringing it into our existing basins. And the add for us is that we'll take it in here rather than just dropping it in right away. We're going to take it, put it in a long linear swale and slow it down, use it, put plants in here, and then drop it into the space later on when it has to go in there. Esther Brooks, the last little bit here on this one. So one of the things about GILID that we don't really talk about is looking for swales and chicanes and different techniques, but this is one that we should think about all the time too. It's just removing impervious surfaces. And so we're working with McDOT on trying to cut down the lane. There's a huge kind of open space of asphalt that you can't drive in, it's just open. So what we're pushing the lanes over to 2 lanes on this side and then turning this into a landscape median that will pick up the water off of Esther Brooks and bring it into the project as well. The last couple slides here about data collection. This is the part that I think is really important. We can install this stuff, but if we don't know how they function and we're not using, we're collecting data on how long they last and what benefits they have beyond just capturing water, I think we're missing it. So the different types of data collection that we're looking for, water quality and volume. We want to measure flow rates, infiltration rates. We want to understand how soil moisture, how the soil dries up after a storm and how long it takes for that to happen. Does it happen? Does it improve over time as plant materials mature? We have the ability to measure rainfall precipitation right here on campus. We're a flood control district. We have a gauge right outside that does that really well. We want to understand how we can address irrigation variability. And then again, we're starting to get into some of the other kind of co-benefits with thermal comfort. So we're looking to have ASU come around with the Marty cart and measure temperature post-construction. And then again, a few years down the road as plant materials begin to mature, looking at soil health. And then again, these are just data points we can collect as the plant materials grow. And that has a whole bunch of impacts on how these things function. And then again, we want to be able to go back. Did we get it right when we modeled it? So model it in the real world and see how it actually performs. And then looking at runoff rates as well. And then that similar stuff. So the research opportunities, right? We really want to be able to measure how these things capture water. Are they helping to reduce the overall volume in a rainfall event? Are they reducing peak flows? Are we improving water quality by introducing plant materials and running the water through the landscape instead of it just off the roof, onto the parking lot, and into a storm drain? Infiltration rates, this one's really important from my end. I think down here, we're talking about this green elements to improve function. For me, you can dig a swale and put water in it. Once we introduce plant materials, how do those plant materials help improve the functionality of that feature over time? I would say that they do. I think they increase infiltration rates, they break up the soil, they improve the soil's infiltration, cool the air, create microsites for other plant materials. So there's a whole bunch of stuff in here that we were looking to outside community as well as ASU to get involved in doing research and doing write-ups on this function and performance. So again, kind of going back, why does it matter? We're in a drought, 23 plus years, one water approach. I know you all heard that before, but it's important to restate. We look at water as all one water. We need to include flood and stormwater. It's just not nuisance water that we get rid of. It's important. We look at wastewater. We should be looking at this as well. And so how does the district get ourselves involved in it? And it's not just not new supplies, but continuing to look at that demand reduction, right water for the right use. Deborah and I were talking about that earlier. We spend a lot of money pumping water from the Colorado River to here and then cleaning it up to potable standards, pumping it through infrastructure to your house, and then put it out on your plants. We should just take the rainfall and do that. It's a lot cheaper and it's smarter. And then part of it is influencing perceptions of desert landscaping. If we don't change everyone's mindset on how to have a desert landscape, then we're missing it all together. We're still using too much water. We use 70%, is that correct? Out of our residential water uses on outdoor landscaping. We need to change how we view a desert landscape. And then for me and the district, the really important thing here is to try to get GILID to be a vetted tool for flood control, to show its impacts. Riverside County has the LID manual that they allow these features to be used as offsets. And I think it's time that we get to that place as well. Then again, and this is speaking to the choir, but more evidence-based design we have, the more resilient solutions we're going to have. So next steps on this is where we're at right now, which is I thought the whole presentation was going to be, is we're right in the midst of pre-construction services with a construction manager at risk. So they are on board, they're reviewing our plan set that's already done, and then they'll give us some comments and move forward with putting together a guaranteed maximum price. Once we have that and everyone is comfortable and we've got buy-in from upper management, then we can begin construction, which we're targeting for this summer. And part of this is establishing an MOU, memorandum of understanding with ASU as having this be a long-term research site. Something that's really important. We'll go to site certification following after what Norman and ASU have done. We'll see if we can get there. Big, long discussion to be had, but that happens after we finish construction. And then again, this O&M manual and maintenance contract. We are putting together an O&M manual as part of the design work. And the idea is to do it differently, not have the standard practice of chop everything, prune it into a ball. We're talking about doing things differently, and we want the maintenance contract to reflect that. So we want to go back and renegotiate the contract here so we pay them to not do the things that they normally do. And then the last bit here is the education and outreach component. We want to have a walking trail. We want to have a virtual tour and kiosks out there, bring in students, and then anyone who comes here has an opportunity to look at it and access our data so they know what's happening.